Okay, now. Awesome. Thank you, Fabian. Okay, so we're going to find trigonometric ratios using right triangles and use trigonometric ratios to find angle measures in right triangles. So we're going to stick to right triangle stuff. So before we use like Pythagorean theorem, and we also use some other stuff, but right now we're going to jump into trigonometry. Okay, the word trigonometry comes from two Greek terms, trigon meaning triangle and metron meaning measure. The study of trigonometry involves triangle measurement. A trigonometric ratio is a ratio of the two lengths of two sides of a right triangle. One trigonometric ratio is a triangle ABC is AC over AB. So when they're talking about that, you can have this part here, AC over AB. Okay, by asimilarity, a right triangle with a given acute angle measure is similar to every other right triangle with the same acute angle measure. So that's pretty cool. So if you know that one with this one here, then you know it's similar to every other right triangle like that. So trigonometric ratios are constant for every given angle measure. So I'm just going to jump down over here if you don't mind. Put that over there. Okay, guys. In triangle ABC, if triangle ABC is a right triangle with acute angle A, then the sine of angle A, written as sine A, is the ratio of the length of the leg opposite angle A to the length of the hypotenuse. Okay, so sine of A is the ratio, guys. Sine of A, this angle here, is equal to the opposite side over the hypotenuse. Okay, so in regards to angle A, this is the side opposite of it. Cool. Sine of B now would be the same ratio, opposite over hypotenuse. So sine of B would sine of B would be equal to the side opposite over the hypotenuse. Okay. So I know you've never seen these words sine, cosine, and a tangent. So this is what you said, sine, like a sine, like S-I-G, like that, sine. That's the way this sin, we still say sine of A. Okay? So when you talk about sine of this angle A, it's equal to the side opposite, also known as A. That's a fraction. It's equal to this fraction. Opposite A, the length here, over this length here, your hypotenuse. That's it. Okay, so you got to learn these things. Cosine now. Cosine is the same relationship, but regarding A, it's going to be now. Y'all need to know what A adjacent means right here. Adjacent is the one next to it. See, sine of A is the one opposite. Adjacent, cosine, adjacent is the one next to it. See this side here? Why can it not be this side here? Because regardless of how you look at this triangle here, this one here is your hypotenuse every single time. Okay, so cosine of A, cosine of this angle here, is the side adjacent over the hypotenuse. It's going to be, again, cosine of A would be the one adjacent. How do I write it? ATJ over the hypotenuse. Okay. Tangent of J, or tangent of A. Tangent of A is now going to go ahead and be written as the one opposite over adjacent. So do me a favor, guys. Write this down, or write this down right here. And just know it as so ka to so ka toa. You know mine? So write this down. You do need to write or draw this triangle here. And this O, the opposite. Where you see O, that's opposite. Anytime you see the H, that's hypotenuse. Anytime you see the A, it's adjacent. Let me see if I can move it up a little bit. So here are trigonometric ratios. And I go again. So, ka, so, yeah, I would say write this down here. Really, all you need is the A part. You're cool with me. Do draw this triangle, and then make sure you know this part here. I guess this red box. Okay, guys, while y'all are writing that down, I'm going to let you know we have a benchmark in about 1 month, okay? We have about a benchmark in about 1 month. I think it's March 9th, the week before spring break. So we need to basically, I'll start reviewing in about a week or two, okay? But I'm going to start throwing in some, I guess, little quick, practice problems here and there. Okay, so here we go, guys. Remember this. Please write this down. So, ka, to, You know, okay with that one? Write that down real quick. And what does so stand for, guys? Okay, so remember sine. This is going to be your sine. Okay, it's going to be this one right here. This is your cosine. And this will be tangent. So katoa, so sine, we'll go with A, or any angle, is equal to O over H. What does O stand for? Anybody remember what O stands for? Somebody remember what O stands for? Opposite. What does H stand for? Hypotenuse. Okay. So katoa, y'all okay with that one? Now what does ka stand for? C-A-H. Anybody? Okay, cosine. And what does the H stand for? Come on, guys. What does the A stand for? Anybody remember? That's the one that a lot of people have issues with. Adjacent. Adjacent. What does the Y stand? What does the H stand for? Again, hypotenuse. Last one's TOA is tangent. Tangent is going to be opposite over adjacent. I'm going to make sure my mic is on because it always still asleep. Okay, so we're good there. What do y'all think? You got it already? Again, SOHCAHTOA, SOHCAHTOA. So now I want you to come back to this thing right here. Pay attention to my thing. If I ask for the sine of B, you need to know sine means what? So opposite over hypotenuse. So what's the side opposite of B? Little b. You got that? Over hypotenuse over C. You understand that? What if I say cosine? We will only add sine and cosine of A and B. Okay? What about sine of A? Well, sine of A still stands for so, right? Still stands for the side opposite, A over C. It's this ratio, guys. It's this ratio that we're looking for. Let's go and practice one real quick. I think y'all just need to throw some numbers at y'all. So here we go. Let me zoom out so you can see them all. There we go. So let's come on here. Express each ratio as a fraction and as a decimal to the nearest hundredth. Sine of P. Okay, so let's come out here and find sine of, remember sine, so, right? Opposite over hypotenuse. So here, what's the side opposite of P? Anybody know what's the side opposite of P? How about this? What's the length of the side opposite of P? Anybody? Somebody. Alessandra? What's the side opposite of P, guys? Come on, somebody. Look at the chat. Now, the answers are all right here. But let's look at that. The way they come up with these answers. The opposite side is 15. We're looking for a fraction right here. We're looking for a fraction. What's the hypotenuse? And that's how they get these numbers. Okay, now let's look at the next one. Remember, SOHCAHTOA. Cosine. Cosine. That's ca, right? Ca, like this. What's, wait, P. Cosine of P. Where's P? What's the side adjacent? The side next to it. That's opposite. We already figured that. That's opposite there. What's the one adjacent to it? Right here. So it's going to be 8 over your hypotenuse, 17. So do you see this ratio stands for this numbers here when you do sine of P. When you use a cosine of P, it does adjacent over this one. Okay? It's this one. Okay, let's do tangent of P. P is over here again. TOA. TOA. Right? Opposite. Where's P? Opposite. 15 over adjacent 8. Does anybody have any questions as far as how to get or how to establish which is opposite and which is adjacent? Anybody? Come on. Wow, guys. They give you one extra day off, and then you all are asleep. Okay, let's see. Ready? So we're going to go sine of q. Sine of q is over here. Okay, now remember sine. What does the word sine stand for? Sine means so, right? Opposite over hypotenuse. So the opposite side is 8 over the hypotenuse, 17. Okay, there they are. There's cosine of q, tangent of q. Okay, let's go and do this one real quick. Number 1. Copy that down real quick, guys. Let's get it done. We can copy it down. Make sure we're looking for sine j, sine of j, cosine j, tangent of j, all these things. Okay, let's go. Ready? So that's, guys, I need your in the chat here, I need you to get active, guys. This right here, where you're still asleep, does not count. Not good. So help me out, right, guys. Let's go and find sine. First off, let's establish the SOHCAHTOA. SOHCAHTOA. Let's go on sine of j. Sine of j. How do you get sine of j, guys? What numbers? Come on, just give me the two numbers. You can leave the spaces alone. I understand the first one will be the top one. The bottom number will be the second one. Anybody? Come on. Sine of j. Remember, sine stands for opposite over hypotenuse. J is right here. Opposite would be, you see this, Eileen? Opposite of j. This is the angle j, the one opposite is 5. Hypotenuse, 13. Good job, Eileen. Thank you so much for participating in that one. Let's go, guys. Let's go. Eileen, the one next to it, that's what adjacent stands for. The one right next to it, touching it. Okay? Cosine of J. Let's get cosine of J. I guess capital J. Cosine. Remember, cosine is adjacent over hypotenuse. Okay, ready? Again, adjacent. This is talking about J. The one next to it, right here, 12. Good job. Good job, Eileen. You're a question ahead. Over hypotenuse, over 13. Okay, guys, looks like some of you are having issues. Pay attention real quick. Look at the thing right here. If I'm talking about J, what's the side opposite? According to J, this would be opposite. Oh, wait, sorry, opposite. Adjacent, this would be it. Okay? Now let me switch it up and change color. Talking about K, this one over here is opposite. You see how it's the opposite side? And then this one next to it here would be adjacent. Either way you cut it, this is always going to be your hypotenuse. Okay? So let's come back and let's work on that real quick. Cosine, sine, cosine, and then what's the last one? Tangent. Tangent. Now, tangent is OA, opposite over adjacent. We're looking at J. The opposite one would be, good job, Eileen, over adjacent, 12. Perfect. Not too bad, right? Not too bad. Okay, now let's do, set these up, guys. Try these on your own. Try the sine. Okay. Cosine, okay, and tan, okay. Set those up real quick, let you look at them. Here we go, ready? Sine of K. Let's look at sine of K, sine. Okay, anybody? Sine of K. Let's look at, again, sine. Sine. Opposite over hypotenuse? K, we're talking about K, which is opposite. Anybody? Opposite over hypotenuse. Good job. Josh, good job. Anybody else? Come on. Let's go, guys. Snap out of it. Now we're doing cosine of K. We're talking about K. Cosine of K. Cosine. Adjacent over hypotenuse. So, right, did you get it? Alessandra? Y'all showed up a little late. Here, come on. What do y'all think here? Cosine. Adjacent. I like that. Over hypotenuse. Good job, Eileen. Perfect. Tangent of K. Tangent of K. Come on, guys. Let's go. Come on, David. Sam, do you get it now? 12. TOA. TOA. Opposite over adjacent. Opposite over adjacent. 12 over 5. Good job, Matthew. Good job, Eileen. David. What happened there, David? Kind of, Sam. Oh, now I got you, David. My bad. Good job. Okay, questions over that one, guys? Yes? No? Maybe so? What do y'all think? How do y'all feel, guys? Y'all want to practice another one there? How do y'all feel, guys? Yes, no, maybe so? Wait, can you go back? Okay, guys, so we're going to stop there. I gave you an assignment on Alex because you all did not convince me that you know how to do this stuff. I gave you 10 questions. Tomorrow we'll finish up this section. It does not get any easier. If you look what happens here, we're going to have to solve for some x's. You all are still asleep. Not cool. Yes, we're going to solve for some unknown things here. Solving for your x's. And we're going to have to use your calculator. So please get your calculators ready. Jai, you're not allowed to leave, Jai. You're not allowed to leave. We will solve for some x's, for some unknowns here. It becomes more interesting, so you better know how to set them up. Then we'll be doing some inverse sine, inverse cosine. So let's get ready, get it to it, do it to it. Going once, going twice. Please charge your calculator today, guys. We will use it tomorrow. Okay, you're going to have to use a calculator for some of this stuff, and it should be super duper mega fun. Come on, guys. Y'all are waking up a little too late today. Come on.